So I thought I would commit a little bit to a model. Um, Basically, I think the photon is when you have the orbitals in a higher energy state and then they drop to a lower energy state, they send out a certain amount of energy. So the weird thing is, since energy isn't a continuous thing, you can't divide it. As the circle of the energy goes out as the ripple, you can't divide it because there's a minimum amount. It's either zero or it's a whole amount in a particular area. So that's weird, and that creates the idea of a photon, which I think is just entanglement. You're entangled with having detected the ripple at this location. Somebody else at a different location could be entangled with it at a different location, and they would have a different set of information that entailed based on the entanglement. Entanglement's easy to destroy in nature, but the human brain, being an entropy pump, um, maintains entanglement. That's what information is entanglement. So basically, my model is that the photon is an ephemeral phenomena that's a cross section essentially of the full data set that comes from whatever is causing this weird quantification of energy. Now, as weird as the quantification of energy is, we know if energy was continuous, we would have had this thing we had called the ultraviolet catastrophe, where there's an infinite amount of energy at certain wavelengths, and like that can't be. So whatever, it turns out that the energy is quantified, which means that instead of being divided in space continuously, there's a point at which it's not divided, and it's either in this pixel or that pixel of the Planck, the Planck region or whatever you want to call it. And it's a special weird thing that we'll deal with later. What's really going on that's not so weird is that atoms have a shape. When I was a kid, they were still saying, oh no, they're shapeless or whatever. This is a neon atom. What are we looking at? This is a neon atom. The nucleus is down there at the center, not really even visible. And then what we're looking at is the electron shells. That blue one um, is the first shell. Like that's the shell that a hydrogen atom has, and it can have two electrons in it. If it were to get excited in a hydrogen atom, it would splink out into these other bubbles, right? This is a bubble, like a magnetic soap bubble. That's the electron, that shell. And two electrons can contribute in there and join together and act like a boson. And then there's another shell that's spherical, this red one. And then after that, you have these p shells, which are these dumbbell shapes, or, there's three of them here for the three dimensions. One this way, one this way. What we're looking at is neon, where all of these shells are filled. Each one is a pair. 2, 4, 6, 8, 10 electrons. And that's neon. And its electrons are all filled up, so it doesn't really want to react with anything. Because the thing is, when one of these little nodes has just one electron in it, it wants to pair up, whatever reason. If this shell bumps into another shell uh, where there's only one electron in that shell, it'll want to connect. So a hydrogen, if it bumps, so this is 10. When you have oxygen, here's another way of drawing it. These shells all have two electrons, and the pink and the yellow have one. So if another oxygen comes up here and it's yellow or pink bumps into this guy, they're going to want to share an electron. So they'll spark together. The electron from the hydrogen or whatever the other atom is will start to flow in and around the nucleus of this. You have what's called a covalent bond. And this pairing is satisfied by sharing an electron. both of these satisfy the pairing, even though there's still an electron missing, right? So when an oxygen hooks up with two hydrogens, the oxygen gets an extra two electrons, so it fills out to the 10 that it wants, and the hydrogen, which was at 1, fills out to 2, which it wants. However, they're sharing electrons with each other, and since there's a lot more positive charge inside the oxygen, the electrons that are going, when there's essentially 10 electrons flowing around it, there are too many. There's an extra attraction back to the hydrogen. So what happens is these magnetic soap bubble electrons, they're not exactly evenly shared, and it creates the polarity of the water molecule. The oxygen becomes slightly positive and the hydrogen slightly negative. Is that right? I always forget. No, no, no. It's the other way around. The hydrogens become slightly positive because they're sharing their electrons away to something that has a greater positivity than themselves. And so the math all works out about how the charges spread out. And one reason that it's pulsed looking like this, these bubbles, is because these bubbles are all negative. So they want to stay away from each other, right? The bubble would like to stay, and there's a threshold where it stays away from each other, but is attracted to the positive in the nucleus and is connected through this Cooper pair system where these things want to pair up. So in neon, where it's already paired up, it doesn't want to react with anything. In oxygen, there's two of these waiting for pairs, so they're ready to share electrons. And then you have a Lego system where things plug together. Now in the oxygen is 8, carbon is only 6. So the issue there is that carbon wants to be shaped just like this as well. But the problem is, so oxygen has one electron to put in this and one electron to put in there, and so they're all produced, but two of them are wanting partners. Well, the problem is with carbon is there's only enough electrons to go ahead and put one of these in, and so it becomes a hybrid. When you add the waves together from all of these different shapes of the electrons that are coursing through this whole thing as a circuit, you end up with this tetrahedral distortion, basically, of that shape, which is again, like oxygen and hydrogen, very reactive. They want to share all of these guys. See, they all have one, so there's 4 contact points where if an electron from a hydrogen or an oxygen shell bumps into this, it'll connect together and they'll start sharing oxygen. And this is what causes the molecules to bind together. Now, when you shoot energy into something, like if you shoot energy into, let's say you had this blue shell with one electron, that would be a hydrogen with an electron. If you shot energy into it, it would bring, 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 it would bounce out. The extra energy would make it go into this P shape. First this one, and then this, and eventually at a high enough state, all of this. And every transition, as it dropped back down to the blue shape, would release photons, various, very distinct photons that it can release, right? And these energies are also related to what's binding these things together, and what's creating this kind of Lego structure that allows things to hook together at different energies based on the shape of an atom. At a high enough energy, pumped with energy, it'll be bleeding photons, but you could keep pumping energy into a hydrogen, and it kind of creates the shape of an oxygen atom, but just with one electron, and therefore each of these connections is more faint. Yet if it can hit another molecule, it could do this connection, which explains some of the differences of high energy physics. And this is how things plug together. And when this high excited state of hydrogen falls back into its low energy, here the blue orbital state, a photon shoots off and it goes off in a spherical ripple. Because of the Planck constant, the energy can't be divided infinitely along this surface as it grows continuously. And the energy has to be located at a particular point on there when we detect it. If we detect it, we are entangled with that solution, but all of the other solutions still exist, and other things in the universe are entangled with those other solutions. There is no multiverse. We're all one universe, but elements of matter and energy are entangled with different elements of energy and mass and so on. So what's really going on is that you have all of these rocks and things bumping into each other that are entangled, but they get disentangled rather quickly. So, for example, when somebody steps on a beach, they leave their footprint in the sand. The shape of their foot is entangled, literally quantum entangled, with the sand, which is in that shape and is containing that information of the shape of the foot that stepped in it. You can do the same thing with a rock, rolls down the hill in a little landslide, lands on the beach, and leaves its imprint in the beach. While it's still sitting there, it's made its imprint in the beach. They are entangled information. The thing is, as time comes and the rock is washed away and the sand is remixed, the information of how the rock got there and the path of the rock to get where it is now, and that's all erased, right? Which is the same as disentanglement. When you erase information by randomizing it, by shredding it, but truly shredding it beyond, putting back together, it's the same thing as an unmeasurement. You had entanglement, and you are removing the entanglement. And, the second law of thermodynamics with the entropy is that entanglement tends to disentangle, right? But the human brain, with the entropy pump, and all other living creatures, seem to maintain that information, right? So we maintain the entanglement. We maintain the consequence of one thing happened and then another, because physically we are, remembering or maintaining our connection to uh, information that physically happened. And so when the photon goes out in this bubble, we are getting entangled with it having arrived at a particular point. But in reality, that's just because, since information has discrete quantified, quantified amounts, it has to exist in a particular location as opposed to being infinitely devised by the surface area of an expanding, spherical wave. So, Ann Pelosi was going to say something on Pelosi.